Okay, on the first weekend homework, one of the questions asked you to determine or to find 3 points on a graph of your water depth versus clock time as you observed it in class on Friday. So the best graph I got, we could use the points 4:25, 13:15, and 19:10, where the 4, 13, and 19 are clock times in seconds, and 25, 15, and 10 are the depths in centimeters that correspond respectively to those clock times. If we plot those 3 points, we see that we can we can sketch a very plausible curve through those points. Okay. Now, a quadratic function. You might or might not know what a quadratic function is, but a quadratic function is a function that has a t squared term, a t term, and a constant term. Okay, the t squared term is going to have a coefficient, some multiple of t squared. The coefficient of t squared we're going to call a. That has a t term, and the coefficient of that term we're going to call b, and the constant term we're going to call c. Now, if this is the model, if this is the curve, then from these 3 points we can determine the values of a, b, and c that would make the curve actually go through these 3 points. And this isn't particularly difficult to do, although it's a little more involved than what you did with the linear functions. There are 3 equations, among other things. Okay, so we have 3 parameters to determine, a, b, and c. We need one equation, one independent equation for each of those 3 parameters. So to get the 3 equations, well, let's just take the point 4:25. Okay, that means t is 4, y is 25. So y is 25 when t is 4. So we can plug in 25 for y and 4 for t, and we get an equation. Okay, now then this, if the graph is going to go through this point, then whatever a, b, and c are, when we plug in 4 for t, we have to get 25 for y. Otherwise, the graph doesn't go through this point. This won't be a point on the graph. So here's one equation. Okay. Now this equation can be rewritten. 4 squared is 16, so we have 16a. 4 times b is 4b, so we have 4b. You see, I've got 16a up here and 4b here. You can ignore all these arrows. They come about a little bit later. So just concentrate on the stuff that's in white right now. Now I've rewritten this equation. I've put the 25 on the right-hand side and the 16a plus 4b plus c on the left-hand side. Then I asked the class to give me the corresponding or the equations that correspond to this point and this point. So everybody did that successfully and without much trouble. Plugging 13 in for t, we get 169a, so we have that. 13 squared is 169. So we have 169a, and plugging 13 in for t, we get 13 times b, right there it is, and we get c. C doesn't depend on t, and the y-coordinate is 15, so we have 15 on this side. Similarly, when we plug in 19, 10, 19 for t, 10 for y, we get the 10 on the right-hand side. We get 19 times b. 19 squared is 381, and good heavens, what did I do? It's 361, not 381. Okay, so there's a big error alert right there. Now let me make a little note. Okay, bug alert. 19 squared is 361, not 381. I actually think I said 361 in class, and something made me write 381. One way or the other, it's on me. So that's wrong, which means this whole model is not quite right for these points. Turns out that it's not that far wrong, but it is a little bit off. So any little discrepancies we find in trying to verify our results are probably going to be due to my 381 there. Okay. In any case, we have these three equations. We have three equations and three unknowns. Now, we solved linear equations yesterday by eliminating a variable. We had the mx plus b, and we eliminated the b variable because it was very easy to eliminate. We just subtract one equation from another and b goes away. We can do the same thing here. If I was to subtract any one of these equations from any other, they would both have just plain old c here, just a plain old 1c. So that when we subtract the c and the one from which we're subtracting is going to be essentially canceled out by the negative c that we get when we subtract, and we're going to get 0. So that's what we're going to do. Now, I did this in some detail up here. I said, okay, I said any two of these equations. We take the second equation and subtract the first. I do second minus first because the numbers in the second equation are mostly bigger than the ones in the first. So I get fewer negative signs when I subtract. And it's often a good idea to avoid negative signs when you can, and be very careful about them when you can't avoid them. Simply because when we start doing negatives of negatives, things are easy to confuse. So if we're interested in doing our work accurately, it's a little better to subtract the first from the second than to subtract the second from the first. But it could be done either way. There's no compelling reason why you have to do it that way. In any case, that's the way I did it. And so what I've done is I've written down the second equation, 169a plus 13b plus c equals 15, second equation, repeated here, and labeled that the second equation. Then I've done -1 times the first equation. Now, I could have just written the first equation down here and subtracted, and that probably would have been okay. But I prefer to multiply through by -1 and then add. People make more mistakes when subtracting than they do when adding, even if there are negative signs involved. And if you're subtracting and negative signs are involved, then it gets really easy to make an error. It's not all that confusing, it's just hard to keep it all straight and keep your concentration and not make mistakes. Okay, well, so the second equation is this, -1 times the first equation is this. And I've just taken the first equation and changed all the signs all the way through. Now, if the first equation is a true equation, then if I multiply the first equation by -1, it's still a true equation, as you would know. Okay, so I add the second equation to -1 times the first equation. 169 and -16 is 144. 13 and -4 is 9. C and -c add up to 0, so I don't have to write anything there. 15 and -25 add up to -10. So my second equation minus my first is 144a plus 9b equals -10. Now my third equation should have been 361 instead of 381, but we'll go with the 381 here and understand that there's going to be a little bit of an error in our final result. Okay, so I do the third equation, and we have to now, we've done the second equation minus the first. We've got an equation in A and B. Why do we need to do another one? Because we've still got two unknowns. We're going to need to get another equation in A and B in order to then be able to solve those two equations to find the values of A and B. So we pick another pair of equations, and people wanted to do the third equation minus the second. Okay, that was a choice somebody in the class made. That's fine. That's what we did. So here's the third equation, mistake and all, and the second equation times -1. So I've just written the second equation down with all the signs changed, and then I do the arithmetic. I get 212a plus 6b equals -5. That should be fairly obvious to you. Now I repeat those two equations here. I circled them with yellow chalk, and now I've written them down in yellow here. And now what I want to do is I want to eliminate one of the variables. Now you want to probably pause for a minute and think, how am I going to eliminate a variable here? In every case that we've done so far, we have a variable that appears and in both equations, and just that variable appears so that when we subtract the equations, that variable goes away. That's not the case here. We've got 144a, we've got 212a, but clearly that's not the same. We've got 9b and we've got 6b. That's not the same either. So what are we going to do about that? Well, the answer turns out to be fairly simple here. First of all, we're going to try to get rid of b just because the numbers are smaller and probably easier to deal with. Also, we have the advantage that the numbers have a common divisor, 3, and they're in a simple ratio of 3 to 2. Okay, 9 is 3/2 as big as 6. So what we're going to do is we're going to take the first equation, and then we're going to multiply the second equation by -3/2. Because when we multiply 6 by -3/2, we get -9. So our second equation, 3/2 of 212 is 318. That's pretty easy. You can do that in your head. Half of 212 is 106. So if I add half of that, half of 212 to 212, 106, 212 is 318. Of course, it's a negative. And we get then -3/2 times 6 is -9. That's easy. And -3/2 times -5. Well, 3/2 of 5 is 7.5 or 15/2. 3/2 times 5 is 15/2. -3/2 times -5 is a positive 15/2. So here are the two equations, and the b terms are lined up so that when I add these two equations, the b goes away. And I end up with -174a equals -5/2. Now, I can easily solve that for a. I divide both sides by 174, and I get a equals 5 over 348. And we can do this in our head. We don't need to reach for a calculator to do this. And we want to reach for a calculator if we want to do the decimal equivalent. But just to do the fraction, certainly I can multiply 174 by 2. And certainly you understand why we have to multiply 174 by 2 to get this solution. So the solution is 5 over 348. That's approximately 0.0144. I estimated 0.0145. It's easy to estimate this. 348 is pretty close to 333. And dividing by 333 is a lot like multiplying by 3. 3 times 5 is 15. A couple of decimal places, we get 0.015. But 348 is a little bigger than 333, so we've got to make it a little smaller. How much bigger? Well, 15 bigger. 15 out of 300 is about 1 part in 20, and so forth. So you can adjust this. If you can do a little bit of mental arithmetic, and it's worth being able to do that. Don't expect you to go that far, but if you keep thinking about it, you could develop the ability to do that, and I believe it's an important ability. Not just because I have it, everybody in my generation has it. We didn't have calculators. But because it helps you think about numbers, think about quantities, visualize, and so forth. So now we know that a is 0.0144 to 3 significant figures. People verified that with a calculator. We take this and we plug it in to this equation, and we get our value for b. Now, my arrow goes to b. The 0.0144 should go in for a, so I'm going to correct that. Having obtained a equals 0.0144, we plug it in for a, and we solve the resulting equation for b, and this is very straightforward. We get b equals -1.34. We then take our value of a and our value of b and follow these red arrows up here and plug in the a value and the b value in any one of the equations, but it was easiest to draw the arrows to the first. We plug those values of a and b in, and we solve for c, and we get c equals 30. So now we know that our quadratic model here, except for my little error with the 381, should be 0.0144 value of a times t squared plus -1.34 times t plus 30.